this dizzy life and put my feet in the grass. I'm going back to the earth. I'm going back to the earth. I'm going back to work. I'm going back.
Hi, second graders. It's Mrs. Kelly here for our last week of learning together. Take a look around me. I am taking a walk in the woods this week. You notice there are a lot of trees around us, and that goes perfectly for our math lesson this week. Our math lesson this week is going to talk about a new type of math that you guys may or may not have heard of called multiplication. And when we multiply, what we do is take groups of things and add them together over and over. And I was looking around and seeing there are a lot of trees in this woods. So one way that I would count them all is I might think about how many groups or rows of trees and multiply to figure out how many trees all together. So we will explore the world of multiplication this week. So let's go.
Okay, boys and girls, so it is time to talk about multiplication. And in order to understand what multiplication is, I'm going to show you a couple different ways to explore what it really means. And the first way is by looking at what's called an array. An array is a group of things coming in rows or columns. And if you can look at this array, there are 3 columns with 4 things in each row. So you can see 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we see that there are these 3 groups of 4, but we need to be able to figure out how many altogether, right? So if we wanted to add, we simply could do 4 plus 4 plus 4, and we would find the answer to be 12 if we added up 4 3 times. But a quicker way to say that, instead of doing 4 plus 4 plus 4, we could just say 3 times 4 and get the answer 12. So really, when we're multiplying, the first number is telling us how many groups, and the second number is telling us the number of things in each group. So there are 3 groups. See where we see them: 1, 2, 3. And in each group, there are 4 things. So if we do 3 times 4, we would get 12. It's the same thing as adding up 4 3 times. Let's look at another way of looking at it: equal groups. So in this case, it's the same problem we're seeing here, 3 times 4. But in this case, we're seeing them as groups in the circles instead of in rows. But essentially, it's the same problem. There are 3 groups. There are 4 things in each group. So 3 times 4 equals 12. Again, we could add up 4 plus 4 plus 4, but a quicker way of saying it would just be to say 3 times 4. Okay, let's move on and see if we can look at one more way we can think about it. And this is called repeated addition. So again, instead of adding up 4 3 times, it's just quicker to say 3 times 4. The answer is going to be the same, whether we added up 4 3 times or we said 3 times 4, the answer would be 12 either way. Finally, we can look at it on a number line, okay? A bird hops 4 centimeters each time. Where does it land? Well, if it hops 4 centimeters the first hop, and 4 centimeters the second hop, and 4 centimeters the third hop, that's 3 hops with 4 centimeters for each hop. Again, 4 times 3, or 3 times 4 in this case, equals 12. All right, boys and girls, so let's give this a little practice right now. We are going to add first and then translate that into a multiplication problem. So let's check this out. We have over on the left-hand side here, we have 3 columns. These are basically an example of an array. And in each one of these columns, there are 3 boxes. So a repeated addition problem would be 3 because there are 3 in the first column, plus 3 in the middle column, plus 3 in the last column. 3 plus 3 plus 3. So let's figure it out. What do you think it is? We can use this visual here to help us. So 3, 1, 2, 3. The next 3 would make it 4, 5, 6. And the final 3 would make it 7, 8, 9. So 3 plus 3 plus 3 equals 9. But a faster way to say that would be 3 times 3, meaning there are 3 columns and there are 3 things in each column. So 3 times 3 is 9. Let's try another one now. Let's try this one here. This time we have 1, 2, 3, 4 columns or rows, but usually columns are vertical like this. Rows are going across, they're horizontal. So we have 4 columns and there are 5 things in each one of these columns. 1, 2, 3, 4, 5, and then 5 in the other 3 that are remaining. So one way that we could say this is 5 plus 5 plus 5 plus 5. And that would be called repeated addition. And we could think about it like counting by 5s. 5, 10, 15, 20. So 5 plus 5 plus 5 plus 5 equals 20. A quicker way to say that, though, would actually be 4 times 5. Now, they have it written as 5 times 4. The answer is going to be the same, but technically the first one, the 4, would represent how many columns, and the 5 would represent how many things in each column. So 4 times 5 would equal 20. Let's try one more. So we see in this problem, we have 2 columns, and in each one of those columns, we have 4 things. So as an addition problem, we just say 4 plus 4, and we know that that's an addition doubles fact equals 8. But a faster and more efficient way to say that as a multiplication problem would be to say that we have 2 groups or 2 columns times 4 things in each one of them. So it would be 2 times 4. They have it written as 4 times 2. Again, multiplication, you can put the numbers either order and the answer will be the same. 2 times 4 equals 8. All right, so let's practice a little bit more our multiplication skills using the pictures you see on the screen of Boomer. So if I wanted to know how many boomers I saw on the screen, I could use multiplication to help me figure it out. Now, if you kind of look, you see that the pictures of Boomer are set up in rows, or we called them before arrays. So the first thing I want to think about is how many arrays or rows do I have in my array? So I see 1 row, 2 rows. So I have 2 rows. So it's going to be 2 times something. And now I'm going to figure out how many pictures of Boomer in each row. So I see 1, 2, 3, 4. So the multiplication problem for this picture would be 2 times 4 pictures of Boomer in each row equals altogether, the answer would be 8. And another way I could do this is using repeated addition. So I could just do 4 in the first row plus, then I could add on not an equals. Plus I could add on the 4 in the second row and I could get 8 as well. So that's actually just another way to show it. However, when there gets to be more and more rows, the quicker and more efficient way to solve it would just be to use that multiplication problem rather than adding the same number over and over and over and over again. It can get to be a lot of adding, and multiplication is kind of like a shortcut to getting the same answer. So let's try another one. So I'm going to erase these. Let's erase. And let's add on some more pictures of Boomer. So let's see. Let's go down to another row. And let's add some more Boomers in. So there's 1. We'll keep adding them. I'm going to keep going and bumping up this number here. And hey, you know what? Let's go on to do one more row of boomers. So here's another one and another one. And there are I'm certainly sure Boomer would be proud to see so many pictures of himself on our math problem here. And now we're going to try to solve again, but this time the number has upped itself a little bit. So let's first remember when we're doing arrays, see how many rows we have. So I see one row here. Then I see 2 rows, 3 rows, and 4 rows. So there are 4 rows. So remember that first number is how many rows. So 4. Now I'm going to times it by how many pictures of Boomer per row. It's 4 times 4 equals, and if I did 4 times 4, it's actually the same thing as saying 4 plus 4 plus 4 plus 4. My answer would be 16. And if you wanted to check yourself, you could count up all the pictures individually. Okay. And another way of saying that would say, like we said before, 4 plus 4 plus, ooh, we got to slide over here, plus 4 plus 4 equals, and we would also get 16. But again, it's much quicker to say 4 times 4 is 16 than to say 4 plus 4 plus 4 plus 4 equals 16. So multiplication is that secret shortcut that when we have that addition problem, we're just adding the same number over and over and over again, it's quicker to get there using multiplication. All right, so great job. So Boomer helped us out to see really how awesome multiplication can be, especially when you have a number that you're adding a lot of times. So thank you, Boomer, for your help with that. All right, so boys and girls, we have learned what it means to multiply. And the more that you practice and take a look at some multiplication problems, the better you're going to get. Now, the goal by the end of 3rd grade would be to learn all of your multiplication facts and be super fluent and speedy with them. However, that doesn't mean that you can't become a master before 3rd grade even gets here. And why not get a head start in 2nd grade by starting to learn and memorize some of your multiplication facts? So I thought this was a really fun song to help you practice your facts and learn and start to memorize, because each number for the facts has a different song. It's very catchy, and hopefully it will help some of those facts stick in your brain so you'll get really good at it. So enjoy this song and see where it takes you. And the more you listen to it, the more you see it visually, the easier it's going to be for you to learn those facts. So enjoy, and let's get started.
Come on, y'all, get fluid. Now you're fast, then flaunt it. I'm about to break it down. 0s to 12. Check out my fluency. Let's go. All my students, listen up. If 0 is a factor, it takes control, it steals the show, the property of 0. Times 1 is 0, times 2 is 0, times 3 is 0, times 4 is 0, times 5 it is 0, times 6 it is 0, 9, 9, 9, 9, 0. Times 7 is 0, times 8 is 0, times 9 is 0, times 10 it is 0, and 11 is 0, times 12 is 0, 9, 9, 9, 9, 0. I knew ones were trouble when they walked in. In fact, they're so easy, just count like 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, identity, property of multiplication. Do you know I know my 2's? Yes, I most certainly do. Do you know I know my 2's? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, know my 2's. Use that doubling strategy, so easy, but I practice it anyway. Hit me with my threes really please. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. I love me some threes, yeah. If you know you're frozen, you should sing along with me. If you know you're frozen, you should sing along with me. Don't be shy, know you know I'm singing along with me. If you know you're frozen, you should sing along with me. 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Oh no, here come the 5, 5, 10, 15, 20, 25. You know I'm all shortly 30, 35, and 40. And then there's 45, 50, 55, feeling alive. 60's coming, it's true. Now the 5s will spit you adieu. 6s, I just met ya. You're kinda crazy. 6, 12, and 18. 24 and 30. 36 and 40. 2 and 48. 54 and 60. 66 and 82. What was the song for the 7s again? Oh wait, I got it. My mama once told me your 7s could be hard. She said if you practice, then soon you'll be a star. Well, I've been practicing all day, now I can finally say, now I know the 7's on my own. It goes like 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70, 77, and 84. Go on, do those 9s for me. McCarthy said. We got those 9s. 9, 18, 27. I'm just beginning. 36, 45, 54, or 63. Now watch that 70 to that 81, that 90. Yeah. Watch that 99, 108. Oh, life is so great, but it's not with Nay Nay.